Lesson 3.1, the chain rule. So this is more taking derivatives, okay? Notice Unit 3 is differentiation part 2. So this is taking our derivatives farther. We're still using our shortcuts, so still things like power rule, product rule, quotient rule, knowing those, they're still going to come up. We still have to use them within other problems. The derivatives we've already memorized, you still got to know those. We're going to go into more details about how to use some of these derivatives. If I recall, this chapter goes pretty quick. So the one we're talking about today is the chain rule. And the chain rule is used to differentiate what we call composite functions. So things like Fogg and Goff, where there's a function inside of a function, the chain rule gives us a way to differentiate them. So the examples here, the square root of x cubed plus 2, or sine of x squared. The situation where, like here, it's it's the square root of something, so something raised to 1/2, but then there's also an x cubed plus 2. Or it's the sine of something, but there's also an x squared. So remember, you create a composite function by plugging one function into another. So that is the Fogg, like f of g of x. We can find the derivative of each separate function by using the rules we've learned. But we need the chain rule to find the derivative of two functions plugged into one another. So, chain rule. If f and g are differentiable, then the composite function, f composed with g of x, or f of g of x, is differentiable, and f prime of g of x times g prime of x. And what I usually think is take the derivative of the outside, keeping the inside as is, times, and then you'll take the derivative of the inside. So it's the derivative of the outside, inside stays, times derivative of the inside is what we're going to be looking at. So in notation, f prime of g of x, derivative of the outside, keep the inside, then times just the derivative of the inside. There's Leibniz notation up there that allows us to use the U substitution idea. It's probably not the one you're going to be more comfortable with. You're probably going to prefer this notation here, but this is saying the derivative of y with respect to x is the derivative of y with respect to u, and the derivative of u with respect to x. Here's what you guys probably want to hear. Multiply the derivative of the inside function by the derivative of the outside function. Okay? That's the key. You have to do derivative of both of them. There's a little bit of setup that we'll talk about. So, let's look at this example. Maybe. Find the derivative of f of x equals 5x plus 3 quantity squared with and without the chain rule. So, we have 5x plus 3 raised to the power of 2. Before today, in order to take this derivative, you would need to FOIL this out, distribute it. Okay, so when it says to do this without the chain rule, then we need to write f in a different format. Because right now, we have an outside function as something raised to the power of 2, but then we have that inside function as 5x plus 3, and they both have derivatives. So first of all, what is 5x plus 3 quantity squared when we multiply that out? So no derivatives yet, just what is it multiplied out? Sorry, I had to pause. My brain said 60x.
No, it's 50 plus 50.
Yeah, I know. 15 plus, yeah. So 25x squared on the first. Insides and outsides are both 15x, so 30x plus 9. So now, if we take the derivative, 2 times 25, right? And then subtract 1 from the power, so 50x to the first plus 30x. 1 times 30, and then subtract 1 from the power. That is one way to do that derivative. And to be honest, in that situation, it's not bad. Okay? We will have the chain rule because sometimes it is bad, or sometimes it's just impossible. This is one where, honestly, we could go either way, and it's not going to be bad either way. Kind of depends what you need in the end. Now, with the chain rule, so, let's see, yeah. I'm going to write down the original problem. F of x equals 5x plus 3 quantity squared. With the chain rule, we start by doing the derivative of the outside function. What is the outside thing going on? And it's something squared, yes? How do we take the derivative of something squared? Okay, well, you multiply the 2 out front, yes? So we're going to multiply the 2 out front. We're going to keep whatever is inside the same. And then subtract 1 from the power, and so then it's a power of 1 if you want. Not that you have to write that 1 there. That's taking the derivative of the outside function, because it's a power rule. Multiply the power out front, subtract 1 from the power. But then chain rule says now times derivative of the inside. What's my inside function? 5x plus 3. What is the derivative of 5x plus 3? 5. So then we're going to say times 5. Now, you could leave it like such. I mean, technically that's an answer. But I can also show you, if we clean it up, that, guess what, we're going to get that same answer. How do you guys want to clean it up?
Distribute.
Distribute what?
The 2. The 5.
So if I distribute the 2, not wrong though, then we're going to have what?
15x plus 6.
10x plus 6?
Yep.
And then what else do we have though? We have the 5 out back. What can I do with the 5? Also distribute it. If you distribute the 5, what do we have?
150x plus 30.
Hey, guess what? Same answer as the other way? Okay. So, now, I'll be honest. In all honesty, depending on the situation, what I also might do is just here, put the 5 up with the 2 and say 10 5x plus 3. You could do that as well. Okay? Lots of different ways we can go there. So do you see in this situation is one way easier than the other? Not necessarily. Okay? But this is your kind of your proof that you can go either way. And they are the same thing. Okay? But also your proof of, could I have just stopped here and said 2 times 5x plus 3? No, I couldn't have done that. Okay? So we will look at some where we don't have this option of FOILing it out and then taking the derivative the other way. Okay, ready to try example 2? Example 2, given f of x is 4 minus x squared quantity cubed. We're being asked to find f prime. Now, notice she has it written out here, derivative of the outside function times derivative of the inside function. What's my outside function? Something to the third, yes?
Yes.
And notice, instead of me just saying x cubed, I'm saying something. Because does that something matter right now? No. Okay. So and I would say, if you're thinking here, okay, I do agree. The outside function is something cubed. How do we do derivative of something cubed?
3 out front.
3 out front.
4 minus x squared.
Inside stays. Don't change it.
Times squared 2x.
Well, hold on. Raise the power of 2. That's derivative of the outside. What is my inside?
2x. 4 minus x squared.
Negative 2x.
Okay. So the inside function is 4 minus x squared. What's the derivative of 4 minus x squared?
Negative 2.
Yes? I don't necessarily know who it was, and I don't remember if it was one person or 2 people, but let me show you something to not do here, because it happened, and I had to count off for it. What is that doing?
Subtracting 2x.
Subtracting. You have to indicate multiplication somehow here. Okay? And if it's just a positive 2x, it's not as important, is it? But if it's a negative, you have to indicate multiplication there somehow. So there was an issue. I have no idea at this point whose test it was, but someone had that issue. So just parentheses are required in this situation. Now, in terms of final answer, you technically could leave it like this. I would clean it up a smidge. I'm not going to go all the way with it, but if I'm going to clean it up a smidge, I have a 3 out front, and I have a negative 2x out back that are just plain terms, right?
Negative 6x.
So I would write this as negative 6x times 4 minus x squared quantity squared. Do you need to FOIL out that 4 minus x squared? No. Okay. I assume, yeah, that's what my answer key has. Okay. Now, what if we really wanted to, what's the other way I could have taken this derivative?
Negative 24x.
Could we have cubed this out first?
Yeah.
And then taking the derivative would have been easier, derivative of each term, but you would have had to cube it out first. Okay? And Hannah, you were the one complaining about having to cube stuff out last week, so yeah, exactly. You're glad we didn't, so.
Get so messed up with the numbers.
You were struggling with it last week, yeah, I remember. So, okay. We good there? Because I probably have a whole lot of examples.
Yep.
Okay, let's move.
I keep looking up there, and every time it's on
I
the.
need to turn it off. Okay, so
Thanks.
couple of things here. General power and exponential rules. So if g is differentiable, this is kind of what we've already done, but this is saying just the derivative of something raised to the n power. That's what we just did, because we just did some function raised to the third, right? So it's just saying that the idea of moving that power out front, keeping that inside g of x the same, subtract 1 from the power, then times the derivative of the inside. That's what we've already done. The other one we're going to work with, derivative of e to some function. So the idea there is, what's the derivative of e to some power? Or the derivative, I guess what I should say, what's the derivative of e to the x?
E to the
E to the x. So what's the derivative of e to some power? E to some power times the derivative of the power. Okay, because you're going to do the derivative of the outside function, which is e to some power. But then whatever's in that power is going to be the inside, so we'll have to take the derivative of the inside. Okay, so we'll work our way through that. Okay. A, f of x equals square root of x squared minus 1 quantity cubed. I don't want to take the derivative quite yet. What do you need to be able to tell me here?
That is.
Okay, we have to know square root, right? You're never going to leave square roots in calculus when we're talking derivatives and whatnot. So this is x squared minus 1 cubed. And then, actually, no, I shouldn't even write that. We don't need that. We don't need that for calculus, do we? Let me back that up.
I was going to say,
So-
can you just do 3 over 2?
And that's, I was going to take us there, but I was like, wait, we don't need the extra step, I don't think. X squared minus 1, so it is a 1/2 power, yes? This is a 3. 3 goes on the top, 2 goes in the denominator, and so 3/2?
Yep.
Is that okay?
Yep.
Sorry. Okay, derivative. Okay. We're doing a power rule, so 3/2 goes out front. Then what?
This x squared minus 1.
Stays x squared minus 1 inside.
And you subtract 1.
3/2 minus 1. Right? Because 3/2 minus 2/2 is going to be 1/2. And then? We're not having class or anything.
Minus 2x.
You guys agree with their 2x?
No.
I'm just
Where we
asking.
get 2x? What?
Well, I didn't ask
Derivative
you
of the inside.
Okay. So right here,
out of spite.
Yeah.
Kylie was still trying to catch up and figure out where we were. Mario was just being Mario. Are you good now, Kylie?
Yep.
And that's why I was giving him a moment to catch up. Like,
I was like, wait a second, that distracted me.
it wasn't that I disagreed with Hannah. It was just, I need everyone to kind of,
Well, you reel it back in.
yeah. Okay, so we did the power. We subtract 1 from the power times the derivative of the inside. So derivative of x squared minus 1 is 2x, yes? Again, not that you can't leave it like that, but strongly encourage you to clean it up. You're not going to see a multiple choice answer like this because there's a good cleanup that can happen.
Oh, no, yes, well, true.
3x times the square root of x.
Yeah.
Okay, so right here, guys, the 3/2 times the 2x. That's what you need to clean up because 3/2 times 2x is going to just be 3x. So I'm going to say 3x. Doug said the square root of x squared minus 1. I have both in my homework, in my notes. You could leave it as 3x times x squared minus 1 to the 1/2. Or you could say 3x times the square root of x squared minus 1. Here's the deal. Neither of those is more correct than the other. They're both good answers. You need to recognize them both as good answers. It'll depend on the scenario. What are we doing next? Okay? If it's multiple choice on the AP test, which one did they leave it as, right? Okay? Okay, B. -7 over 2x minus 3 squared. Did you just say no?
No.
There's my hint.
Hint.
We don't want to take the derivative yet, is what I'm saying.
That equals.
We want to get rid of the denominator.
Don't shout it out loud, please. Give me this.
Please
And the
don't.
question you have to think to yourself for the moment is, what do we know about that denominator? How can I rewrite that?
Negatives.
Negative
Your mouth.
It'll be an exponent.
Shut
Thank you.
Sorry, you guys are just.
Thank you, you should be.
No, nice Mario.
Okay, this is what I have.
Mario, I love you.
No.
The key is that denominator has to come out of the denominator because we can't take the derivative when you have that power in the denominator.
That's not what I wrote down.
A power of 2 in the denominator, when you move it up above the fraction, is a -2. The -7 was already in the numerator, so I'm going to say -7 times 2x minus 3 raised to the -2 power. Okay. Are we good here? So, what are we thinking here?
14 to the negative third. To the negative third?
Oh, wait. Yeah,
I was about to say
the
it's
negative 3
-2.
would be at the end.
Yeah.
Mm-hmm.
Times 2.
Times 2.
Power rule. -2 times -7 is 14. Keeping the inside as is. Subtract 1 from the power. -2 minus 1 is indeed -3. Times the derivative of the inside. Derivative of 2x minus 3 is 2.
28 times 2x minus 3 to the I take it in 2 steps.
Okay, so 2 times 14 is an excellent move, right? Take the 2, multiply it out front with the 14, you have a 28. And so at first I wrote it as 28 times 2x minus 3 to the -3rd. And then officially, what I'd probably recommend is get rid of the negative exponent, so move it to the denominator. So it was 2x minus 3 to the -3rd. We're going to make it 2x minus 3 to the +3rd in the denominator. 28 stays on top. We're taking all these derivative rules and algebra stuff we already know and just putting it all together. Okay. Ready for the next one? I see multiple people working on the next one. So, moving along. Well, we don't have to rewrite this. It's already ready to go, isn't it? Y prime equals, there's my hint.
2 over parentheses 5 minus 4s to the negative 1/3 times negative 8x. Right?
Yes. Yes. I just forgot my negative.
I can't write
I don't have equations for it today.
Okay. Are we all good on that?
Yeah.
We moved the 2/3 out front, subtracted 1, so 2/3 minus 1 is negative 1/3. The negative 8x is the derivative of the inside. Again, I would definitely clean this up some. 2/3 times negative 8x. Negative 16. Yeah, I'm curious how I wrote that because there's a couple different ways we can write that.
I just left it like that.
Okay, so Sophie said negative 16x over 3, and this is what I was checking I thought I would do. I have mine as negative 16/3 x. It's equivalent, okay, but just having the x next to it. Times 5 minus 4x squared to the negative 1/3. The other piece about that, could you get rid of that negative power?
And I got rid of the 1/3 as well. Well, you know.
In other words, what do you mean when she says getting rid of the negative, the 1/3 power, changing it to a cube root? And that's what I actually have in my answer key. So now, okay, let's see. Fraction bar. I know I need a fraction bar, yes? That 5 minus 4x squared to the negative 1/3 is going to the denominator as positive 1/3. Positive 1/3 is a cube root. So in the denominator is 5 minus 4x squared. Okay, what about this x?
It goes on top.
It goes on top. Negative 16/3.
Negative
Things like that.
goes on top and 3 goes on bottom.
So negative 16 on top, 3 on bottom, or the negative can be outside of the out front of the fraction bar. Okay, so how did I write it? Yeah. The key is to not mess up the little steps, right? It's the little algebra steps that get us. Okay. Stop me if you need to stop me. Y equals e to the 3x squared.
Derivative of
Equals
6x.
Which is just
6x.
e to the 3x. Oh,
E to the
I'm sorry, guys. Okay, sorry.
So, and I think some of you are probably looking at that rule up top. I always say, okay, so right now the whole function is e to some power, yes?
Mhm.
What's the derivative of e to some power?
E to some
E to some
power.
power.
E to some power. So I'm going to say e to the 3x squared. And then times, what do we know about that power? What's the derivative of
6x.
the power? Derivative of 3x squared is 6x. Now, I would never leave it like that because that 6x being out back is just awkward. So you would usually see it written as 6x e to the 3x squared. Okay?
I have that on.
In honesty, when I'm going through that as me personally doing calculus on my own, I'm just going to jump right to that because I can see that. And some of you started to do that, which was fine. But I'm also trying to stay with what I've been teaching, derivative of the outside times derivative of the inside. Okay? E.
Negative 2 times 6x plus 3 on
So if I rewrite this before I start differentiating, negative 2 goes out front, 6x plus 3 in parentheses, a 1/3 power or 1/3 root in the bottom is a negative 1/3, or a cube root in the bottom. That's what I really meant to say. Okay.
Two-thirds.
Yeah.
4/3.
Oh, okay.
yeah,
Hold on. I'm weird at spots. I'm so sorry, guys.
I'm getting a whole bunch of different answers, and I'm really not sure why. So I would look at the fact that there's already a -2 out front, yes?
Yeah.
Times, what am I multiplying it by? Negative 1/3. So this -2 times this negative 1/3 is going to be positive 2/3. Are we good? Times 6x plus 3 to the
Negative 2. Signing over 3 is what I
Negative
got.
4/3.
negative 4/3,
Oh, 3.
because it's going to be negative 1/3 minus 1. So negative 1/3 minus 3/3. So negative 4/3
I did it.
Times 6.
Minus 2.
times the derivative of the inside. Derivative of 6x plus 3 is 6. What do you know?
The 6 times 2/3 is 4.
Agree?
Yes.
2/3 times 6 over 1, so 12/3 or 4. So I could write 4, 6x plus 3 to the negative 4/3. If we get rid of that negative exponent, as we should,
4 over.
The cube root of 6x plus 3 is 4.
Yes.
Right?
yes.
No.
I feel like I'm
So, okay. And this is what I was checking to see how I did it in my notes, because I have a slight issue with what I'm getting ready to write. I'm not sure I would encourage this answer exactly. And it's not that it's wrong, but, well, here's the deal. This is a cube root. This is a power of 4. That means there's a cube root within it. Yeah. I don't know. But on the flip side of it, I struggle with saying this is 6x plus 3 times the cube root of 6x plus 3. Like, I don't feel like you'd see that. So this is a scenario where, I don't know, I might be tempted to leave it as 6x plus 3 to the 4/3. And it's not that I don't have that. I do have that in notes. I don't know. Sometimes with calculus, at least going into AP, the AP test, there's not just one simplified answer, because you don't have to simplify everything. And what is more simplified? Is this more simplified or is this more simplified? I don't know. You know? Okay.
0.
They're all constants, so 0.
Yeah.
There's a theta in there. Disagree.
Yeah, I was gonna say there's
Where's
theta
that?
in there, guys.
Oh,
It's
dang
just a 0. You guys are imagining.
E to the
it.
5 theta. But it's 0 still. That's 0 times.
Okay, so are we saying that all of you that were working ahead now no longer are working ahead?
I was
Is that
never
what's
working
happening?
ahead, but
Okay. Cosine cubed of e to the 5 theta. So e to the 5 theta is the inside of my cosine function. Cosine cubed is saying this function raised to the 3rd. So I'm going to write this as cosine of e to the 5 theta raised to the 3rd. And as we do trig functions, I know it is more common to have the 3 right there on the cosine if it's cosine cubed. However, with derivatives, I think it's sometimes easier to think of it as cosine of something raised to the 3rd. Okay, are we ready to give this a try? What is my outside function? My outsidemost function?
Cosine. Cube.
Something raised to the 3rd. How do we do the derivative of something raised to the 3rd? The 3 goes out front, keeping the inside. So keeping it as cosine e to the 5 theta. The power of 3, subtract 1 becomes a 2. That's my outside function, yes? Times.
I don't know.
I don't know.
Okay, now we're doing what's my inside function, generally speaking. That is the cosine of something. How do we do the derivative of cosine of something?
Negative sec.
No,
Negative sine.
The derivative of cosine of something is negative sine of the same something. Notice I'm still saying the word something. So we just did the derivative of cosine of something and got negative sine of something. What's the derivative of something?
Literally that same thing, right? Because it's e.
What is the
Yes,
derivative?
again.
Okay, so what is the derivative of e to some power?
E to some power.
E to some power times, what's the derivative of e to some power is e to some power times the derivative of the inside. What's the derivative of 5 theta? 5.
Why did we go further?
We just did the chain rule like 3 times in a row
Like, how do you know that you
because you have to.
How do you know you have
Because
to?
God
So-
said, I guess.
Seriously.
Calculus God said. How's that? Okay. Here's the deal, guys. If that had just been derivative of cosine of theta or cosine of x, if I say what's the derivative of cosine of something and it's negative sine of something, and then I say what's the derivative of something and my something was x, the derivative of x is just 1. So that's kind of your done point. But
Oh, so you
if
have to keep going until
you have to keep going and you get to a point where there is no other inside to take the derivative of. Okay, this is typical for them to use multiple chain rules within each other. This is the first one we've seen. But, I mean, as we look at this, and this is why you guys were confused at this one, just staring at it, right?
Yes.
Because you guys saw a cubed, but then you also saw a cosine, but then you also saw an e. And so that's like 3 things, right? 3 different things going on. So we start on the outside and we work our way in. So the outside was something to the 3rd. So 3 something to the 2nd. Then it's times the derivative of the inside. Derivative of cosine of something, negative sine of something. But then can I still take the derivative of that inside? I can. The derivative of e to something is e to something, e to itself, right? But then that something was a 5 theta, so derivative of 5 theta is 5. Okay?
Is that our final answer? I think it should be. You gotta
We can clean it up a little bit. But, I mean, all the pieces are there. Although, I'll be honest, there's not a ton of cleanup you can do. I mean, there is some I would encourage.
15.
15 and then everything else.
Can I?
What kind of 15?
15 e to the 5 theta.
What kind of 15?
A positive.
Positive.
Negative.
Negative
How do you know that?
because it's
Because there's a negative.
But it's in the parentheses and it's not really, and you could leave that piece
But
there.
the 5 is in the e to the theta. The thingy thing.
So, the 3, the 5, and this essentially negative 1 are all coefficients of pieces that we could put together.
So
Okay.
you can put it as sine to times sine of e to the 5 theta.
Right, it would become a positive. So, and I don't know which order I wrote this in.
If we left it as 15 cosine,
It's not that it's wrong.
everything in there.
It's not
times
wrong. It's a matter of
negative
understanding
sine,
the
okay.
equivalencies here. Okay? It's, And so, I would definitely encourage the negative 15. Now, past that, we have 3 pieces. Is there a set order for where those 3 pieces should go?
No.
Not necessarily. However, I would put the e to the 5 theta up with the 15. So negative 15, e to the 5 theta. Whether you do cosine e to the 5 theta squared or sine e to the 5 theta next, I don't know necessarily that there's a right versus wrong on that one. Although I will say I have the sine next. Now, because I took that negative out, it's a
Positive.
positive sine e to the 5 theta. And then the cosine, I got too many parentheses there. You don't have to, but you can. This could just be sine of e to the 5 theta. And then you also have cosine of e to the 5 theta, but it's cosine squared.
I just
So-
parentheses, except for on the cosine squared.
I would, you can put the squared back there right after the cosine instead of outside a set of parentheses. Does it have to be like this to get full credit? No. Okay, our first answer could have been a final answer.
Nice.
Okay, if you've got all the pieces there, I'm going to give you the credit for it. But knowing how the equivalency options are necessary too. Okay, I killed the brains with that one, didn't I?
Yes.
They were already dead. It's not.
Okay, yes,
Is it better to go too far than not go far enough?
not necessarily, because if you go too far and you make a mistake in the process of going too far,
Your answer's
you've lost that point.
If you've really gone too far.
yeah.
I mean, something, if you want simple, something as basic as saying -2 times 3, and then you put your answer as 6.
You forget the negative.
If you left your answer as this, you get it correct. This is how AP grades. You leave it as -2 times 3, they're going to give you a point. They're going to give you the full point. If you put it as 6, they now are not going to give you that point. It doesn't matter that they can see this step here. They're not going to give you that point, though, because you made a mistake. Whereas if you stopped at -2 times 3 and didn't make the mistake, they can still give you the full credit.
So, but what about what I did on that bonus question, where I asked for the group and I gave him a miracle?
He's really in love with that bonus question.
He really is.
I don't know. I'd have to go back and look at it. I don't remember it enough at this point.
Okay.
I'd have to go back and look at it.
Because you underlined
Okay.
the x squared plus whatever.
I have to go back and look. You had a mistake early on in there somewhere.
Right.
Oh, well, you had a mistake that you would have had to, I don't think you would have gotten around. Because I think you added or subtracted, I think.
I did.
Or you didn't apply the negative. So. Okay. G. It's a doozy again. Now, oh, I forgot.
I
forgot what.
Well, there's two different ways we could do this. My brain goes one way, but I forget. Which way's better? Oh. Okay. Sophie's going to complain here.
Sorry, I'm cleaning up my room. There's stuff in it.
Okay. We have logs here. Okay. What are my options? Okay, so there's two things we can do here. But one of those things is, so we have this log raised to a power of 2.
Wait, what?
Who's trying to airplay on here?
What?
Someone's trying to airplay on here.
Probably Stanley, honestly.
I'd say-
probably as Mr. Stanley.
It's like somebody probably hit the
I
wrong
think we're
button.
all a little too focused on calc right now.
We're all trying to
So, like-
understand.
And that's gonna be on the recording too.
So you can go over there and tell Mr. Stanley's AP class that, although no, he eats sea lunch, doesn't he, or not?
I think it.
Pretty minute.
Yeah, I don't know. Okay, anyways,
Who knows?
sidetracked. One option, natural log raised to the power of 2. Okay,
That's not the thing.
that is a thing. But the other thing is, a power on a log. Our log rules say how can you rewrite a power.
Put the 2 to the.
You can put the 2 out front. So before we ever take the derivative, this will make it a little bit nicer, is if you say this is 2 times the natural log of x squared plus x plus 1. Okay, that, I'll be honest, I looked at this, and had I not looked at my notes, I would have taken you the other direction, which would have been a little bit more difficult. That would have been doing something to the power of 2, and then it just gets a little more difficult. So if you can think that way, think that way. Now, the nice part about that, too, is you're doing 2 something. That 2 is just going to stay out front, right? It's 2 times, how do we do the derivative of natural log of something?
I don't know why I want to say that. I don't think that's right.
So do we not remember the derivative of natural log of x?
Oh, 1 over x. It's 1 over x.
Yep.
Okay.
Nice. So what's the derivative of natural log of x squared plus x plus 1?
X, yeah, on top and then 1 over x.
1 over
Oh,
x squared plus x plus 1.
we're done.
Oh, 'cause
Okay.
it's- Yeah.
So derivative of natural log of x is 1 over the insides. How's that? Derivative of natural log of something is 1 over something. So derivative of natural log of x squared plus x plus 1 is 1 over the something times
The inside.
the derivative of something. So now we're doing the derivative of x squared plus x plus 1.
Yeah.
Derivative of x squared plus x plus 1, 2x plus 1. And it'd be a matter of writing it as a final answer. What are options to write this as a final answer?
4x plus 2 over x squared plus x plus 1.
Are you guys good with the 4x plus 2?
Yeah.
I wasn't going to go straight there, but I can.
I'm good with that.
I mean, I was going to go with the fact that, okay, there's a 2 here, right?
Yeah.
But, yeah, it's 2 and the 2x plus 1 are both on top over x squared plus x plus 1. Or what you guys said, I like it, is 4x plus 2 over x squared plus x plus 1. I'll be honest, it is not unusual to see it left in the factored form. So to see it as 2 times 2x plus 1, yeah, this is, these are both good answers.
Wouldn't that be most simplified?
Which one?
Like the top one.
Maybe, because the factored form is sometimes considered more simplified. Okay. You might want to start looking at homework. Do you know how to do a bunch of the homework?
No.
Probably.
Yeah.
Honestly, yeah, we'd have to.
It's just
I mean, we've got through a lot of the basics. It's the trickier ones that we haven't gotten through yet.
Oh.
So you could start working on some of the basics and work on these skills,
Mario,
and then we'll finish notes tomorrow.